Hello students, how are you all? I hope that you all are good. As we know, the series of motion in a plane is going on and we are successfully finished the 19 lectures, right? So in a previous lecture that we are discussing about the formulas of maximum height, time of flight and range. So we got the formula for maximum height, h maximum is equals to u square sin square theta by 2g, and the time of flight is equals to 2u sin theta by g, and the range capital R is equals to u square sin 2 theta by g, and we are solved some applications based on that concept. As usual, at the end of the lecture we are solved some example problems, right? So in today's lecture that we are going to discuss about the trajectory of a projectile is parabola. The trajectory of a projectile is parabola. So that means we have to show that whatever the trajectory of a projectile body is there, that is parabola. So we have some applications on that concept. So as usual, at the end of the session we are going to discuss some example problems based on this concept, right? So shall we start the lecture? Right. So my name is Rakesh Kanaganti. Welcome to our beautiful physics channel, Rakesh Sir Physics. Shall we start the lecture? Okay. So what is the chapter going on? Motion in a plane. Motion in a plane. Okay. Right. So this is a class number 20. Class number 20. Okay. So what is today's concept? Today's concept is the trajectory of a trajectory, the trajectory. Okay. The trajectory of a projectile body, projectile body is parabola. Is what more? Parabola. We have to prove that its trajectory is in the shape of parabola. Okay, sir. Okay, right. So from last two lectures we are discussing about what more? Projectile motion. Okay. So this is the x-axis, y-axis. This is the point A. So from the point A, if you want to bring the object into projectile motion, you have to throw an object other than 90 degrees with the horizontal, then the object makes projectile motion. Right. So the object makes a projectile motion. So when the object makes projectile motion, when we are projected that object other than 90 degrees with the horizontal. Okay. So let us consider the initial velocity of the object. Okay. So the initial velocity of the object is u. With this much of initial velocity, we are thrown that object into the air. Okay. Other than 90 degrees with the horizontal, it makes a projectile motion. This is x-axis and this is y-axis. Okay, sir. So the velocity component along x direction, as we know that. So ux is equals to what? No? U cos theta, and the velocity component along y direction. So what is that? Uy is equals to u sin theta. Okay. Okay, now. So already we are discussing along x-axis and along y-axis the components of velocity acceleration. So ux, initial velocity component along x direction, ux is equals to u cos theta. So acceleration due to gravity along x direction, 0. So the final velocity of the object along x direction, vx is equals to ux, both are same. So in case of projectile motion, the initial velocity component and the final velocity component along the horizontal direction remains same. That is what u cos theta only. Okay, now. So if you comes to y-axis, that means vertical direction, x-axis means horizontal direction. So along y-axis, the initial velocity uy is equals to what? U sin theta, and acceleration due to gravity along y direction. So the object, the change in velocity of the object in case of projectile motion is along y direction. So that's why the acceleration due to gravity acts on the object along vertical direction only. So in a downward direction. So the velocity of the object, the direction of velocity of the object is in upward direction. That means along the path of the object, and the acceleration due to gravity acts in a downward direction. So both are in opposite direction. So that's why we will get minus g here. Okay. So and the final velocity component as a function of time t. So vx is equals to u sin theta minus gt. So this is the final velocity of the projectile body as a function of time. Okay, now. So in a previous lecture we have solved equations for time of flight. We got time of flight is equals to how much more? 2u sin theta by g, and maximum height h maximum is equals to u square sin square theta by 2g, and the range capital R is equals to how much more? U square sin 2 theta by g. So these are the formulas that we are solved in our previous lecture. Okay, right. In today's session, what is our concept? We have to show that the trajectory of projectile body is parabola. So have a look. So whatever the trajectory of this object is there, that is parabola. So we have to prove that. Okay, sir, have a look. As we know that this is a point A and this is a point B and this is a point C. This point B is at a maximum height, h maximum. Okay, na? Right. Okay, I'm going to start this concept. Have a look. I'm taking one object, okay, and I'm projecting this object into an air other than 90 degrees with the horizontal, other than 90 degrees with the horizontal. Now this object makes a projectile motion. So the object is moving like this. So whenever the object is moving like this, and just take its photograph, and just taken the photograph of the object. So at that particular instant of time, when I was take the photograph, the object is at this point. The object is appear at this point. Okay, sir. So now the object is at this point, and I'm just take that film and I'm bring the image of that photograph and I'm stick here. So the situation is like this. Okay. So where is the object is there? So here is the object. Okay, at a point P. Now this point P or the object which is at a point P is at a x distance along x direction, is at a x distance along x direction or horizontal direction. Object is at a y distance along y direction, Now what are the coordinates of this point P? X comma y. The coordinates of point P are what, ma? X comma y. Now I'm going to write the information about that object which is at a point P at a given time. Okay, have a look what is the information of that object. So along x direction, and along y direction, So have a look. Along x direction. What is the displacement of the object? Sx is equals to x. X will be the what, ma? Displacement of the object at a given time t. Okay, sir. What is the initial velocity of the object along x direction? The initial velocity of the object along x direction is given by u cos theta. Okay, now. So what is the acceleration of the object along the x direction? 0. Right. Over. Right. So from this information, I'm just going to write the displacement equation by using third equation of motion. What is that, ma? S is equals to ut plus half at square. S is equals to ut plus half at square. This is along x direction, Okay. So displacement of the object along x direction. What is that? X, that is equals to ux, u cos theta, time. So what is the time? The time taken by the body to reach point P. How much? T be the time. So time T is nothing but T. Ux is nothing but u cos theta. Here T is there. Plus what is the value of Ax? Ax is equals to 0. 0 into something, 0 you will get. So this overall term becomes 0 plus 0. So from this, I'm going to write the equation for time. So time T is equals to, we get u cos theta comes to this side. It becomes x by u cos theta. So this is what the time taken by the object to cover this much of distance, x distance along horizontal direction. What is that? X by u cos theta. So if it comes to y direction, so the displacement of the object along y direction is equals to how much, ma? Y. So the acceleration due to gravity along vertical direction or y direction, how much? Minus g. What is the initial velocity component along y direction? Uy is equals to u sin theta. Uy is equals to how much, ma? U sin theta. Are you getting any doubts? Okay. Again, I am taking the third equation of motion, that is S is equals to ut plus half at square. This is along y direction, vertical direction. Okay. So Sy is nothing but y, that is equals to uy, u sin theta into t. Time is nothing but t plus half ay is equals to how much, ma? Minus g, minus into plus, minus g t square. Okay, let us say this is equation number 1 and this is equation number 2. So equation 1 we have t is equals to x by u cos theta. So I'm just substituting equation 1 in 2. Just substitute equation 1 in 2. So have a look what we get. So y is equals to u sin theta into t. What is t? X by u cos theta minus half g t square. What is the value of t square? X by u cos theta whole square. Okay, na? Right. So y is equals to, here we got, have a look, ma. U get cancelled out. Sin theta divided by cos theta. You will get x tan theta. Are you getting, ma? So u get cancelled out. Sin theta divided by cos theta is nothing but tan theta. Here x is there. X tan theta. That's it. So half g. Here we have x square divided by u square cos square theta. Are you getting? Here square is there, x square, u square, cos square theta. So I'm just writing this equation as y is equals to x tan theta, y is equals to x tan theta minus 1 into g divided by 2 into u square cos square theta, 2 u square cos square theta into, here we have x square, here we have x square. So this equation is called what ma? Equation of trajectory. So this equation is called what? This equation is called equation of trajectory. Okay, so important formula. So what is the equation of trajectory in case of projectile body? Y is equals to x tan theta minus gx square divided by 2u square cos square theta. So x tan theta minus gx square divided by 2u square cos square theta. This equation is called the equation of trajectory. Equation of trajectory. So have a look. From this equation of trajectory, one thing is clear that here theta is constant. What is theta? Theta is constant. Have a look. We are projecting the object by making an angle theta with the horizontal. Once if you are projected, so whatever the angle made by the horizontal is constant. It is not changes. Theta 45 degrees. Throughout the motion, everywhere you take theta is equals to 45 degrees, 45, 45, 45 degrees in all formulas. Okay, it is a constant. The theta is what? Constant. Okay, so and the acceleration due to gravity on any object on the surface of the ground, g value is 9.8 meter per second square or 10 meter per second square. G is also constant. Acceleration due to gravity. Initial velocity, we are projecting an object with a speed 10 meter per second, 10 meter per second throughout the motion. Initial velocity of the object along x direction, y direction, how much? 10 meter per second, 10 meter, 10 meter, 10 meter per second. Everywhere it is constant. That means u is also constant. So theta constant, u constant, g constant. But with respect to the time, the x value will be changes. The x value will be changes. That means, so at any particular instant of time, let us say t is equals to 5 seconds. The object is at this position. If at t is equals to 6 seconds, what happened? It moves forward. So have a look. X value will be changes. At t is equals to 7 seconds, the object comes to here. So have a look. X is equals to increases. After some time, 8 seconds, the object is at a point B. X will be changes. Likewise, so whenever the object is making the projectile motion with respect to the time from second to second, so what happened? X value will be changes. So in this equation, theta, g, u are constants. They are not changes with respect to time, but x is changes. It is variable. X is what, ma? It is a variable. Are you getting? Are you getting what I'm saying? Okay, very good. So have a look. X is variable. Remaining all terms are constant. So that's why I'm taking small a. Constant is equals to tan theta. A is equals to, I'm taking tan theta because it is a constant. And g by 2 u square cos square theta as b. B is equals to g by 2 u square cos square theta. So just substitute here. G by 2 u square cos square theta is equals to how much, ma? B. It is a constant. Tan theta is equals to a. So finally you will get y is equals to tan theta. I am taken as a into x minus g by 2 u square cos square theta. I am taken as b into x square. So we got y is equals to ax minus bx square. Ax minus bx square. What is this? What is this? This is the equation of parabola. This is the equation of parabola. So therefore, it is clear that trajectory of a projectile body is parabola because this equation shows this is the equation of parabola. Okay, na? So hence proved. Okay, right. Are you understood? Any difficulties there? Easy problem, easy thing. Okay, na? So have a look. Along x direction, we are written the components. Along y direction, we are written the components. That's it. So from this, x is equals to u cos theta into t we got. From this, we are written the equation for time, x by u cos theta. That's it. So same thing, s is equals to ut plus half at. Substituting these values, we get this equation. In this equation, just we are substituted the value of time. U cancel out, sin theta by cos theta, tan theta. X is there, minus half g. Here x by u cos theta whole square, x square by this. So this equation, whatever the equation, after substituting the time t in this equation, that equation is called what ma? Equation of trajectory. So what is that? Y is equals to x tan theta minus g x square by 2u square cos square theta. So where except x, remaining all things are constants. That's why I'm written a is equals to tan theta, b is equals to this. Where a comma b are what ma? Constants. Okay. So a comma b are constants. So after substituting a and b here, so we got y is equals to ax minus bx square. This equation shows equation of parabola. So whatever the trajectory of projectile body is there, so that is what ma? Parabolic path. That is what ma? Parabolic path. That's it. Simple thing. Simple thing. Okay. Right. Pause the video and write the notes. Pause the video and write the notes. 3, 2, 1, go. Right. So have a look. We got a equation of trajectory. So what is that? So y is equals to x tan theta minus gx square divided by 2u square cos square theta. So this is what? This is the equation of trajectory that we got. Right. So have a look. We are taken a is equals to what ma? A is equals to tan theta. Okay. So because where theta is constant, then whatever the value we get, that is constant. Okay, right. So and again we are taken b is equals to what now? So b is equals to g by 2u square cos square theta. Okay, so these are the two values a and b. A and b are what ma? Constants. Okay, sir. So from this equation I'm just going to write. So what is tan theta? So tan theta is equals to, we are consider it as small a. Small a. Have a look. In a denominator, nothing is there. I'm just taking divided by 1 as a denominator. Any problem? So from right angle triangle, have a look. In case of right angle triangle, so let us consider this is an angle theta. This is an angle theta. What is tan theta? From right angle triangle, tan theta is nothing but what ma? Opposite side by adjacent side. So this is 90 degrees. So this is an angle theta. What is opposite side? So this is the opposite side, the side which is opposite to an angle theta. So what is adjacent side? The side which is along an angle theta is called the adjacent side. So tan theta is equals to, we got a by 1, that is equals to opposite side by adjacent side. Now what is opposite side? A. The value of opposite side is how much? A. So the value of adjacent side is how much? 1. So from this we can find the hypotenuse. So in case of right angle triangle, hypotenuse square is equals to, we can write side 1 square plus side 2 square. Okay, if square went to that side, then hypotenuse becomes under root of s1 square. What is the side 1 square? 1 square. What is the side 2 square? A square. So a square plus 1 square is nothing but 1. So we got hypotenuse is equals to how much ma? Under root of a square plus 1. That's it. So from this we can write cos theta. What is cos theta? So cos theta is nothing but adjacent side by hypotenuse. Okay. So then cos theta is equals to adjacent side. What is adjacent side? Along theta side. Along theta side. That is 1. What is hypotenuse? Here we got under root of a square plus 1. So this is the value of what ma? Cos theta. And if you want to write the equation for the cos square theta. Okay. So cos square theta is equals to what? If we did a square on either side, what happened? So here it becomes square root get cancelled out. So finally you will get 1 by a square plus 1. Simple mathematics. Okay. So we got cos square theta is equals to how much? 1 by a square plus 1. Okay now. Right. So here we have the value of b. So b is equals to g by 2u square cos square theta we got. Okay now. So from this I want to find the initial velocity of the object. I wanted to find the initial velocity of the object. So just to bring u square to this side, it becomes u square is equals to if b comes to this side, it becomes g by 2b cos square theta. 2b cos square theta. Are you getting me? And just send this u square to this side. So it becomes u square. If b comes to this side, it divides the g. That's it. Okay, sir. So have a look from this. U square is equals to g by 2b. What is the value of cos square theta? So here we got cos square theta value. How much ma? Just substitute there. 1 by a square plus 1. So 1 divided by a square plus 1. So this a square plus 1 value went to numerator. So finally it becomes u square is equals to g into a square plus 1 divided by 2b. If square went to that side, it becomes u is equals to under root of g into a square plus 1 divided by 2b. So this is the initial velocity of the object. This is what? This is the initial velocity of projectile body, projectile body when the equation of trajectory is in the form of y is equals to ax minus bx square, is in the form of what ma? Ax minus bx square. So you should remember ma. Okay, so what is the initial velocity of the object when the trajectory of a particle is in the form of y is equals to ax minus bx square? So u is equals to under root of g into a square plus 1 divided by 2b. A square plus 1 divided by 2b. What is a and b? A and b are the constant in a equation of trajectory. Okay na? Right. So you should remember ma. So we have the problem based on this concept. Okay, let's do the problem. Same concept based on this concept only. Okay, are you ready? Any problem? Right. So 1, 2, 3, go. Right. So have a look the example problem based on this concept. So what they are given? A particle is projected from the origin in xy plane. The particle is projected from the origin in xy plane. Acceleration of the particle in y direction is alpha. Acceleration of the particle in y direction. They are projected one object from the origin. Okay. So the acceleration along y direction, ay given. How much ma? Alpha. So, and if equation of path of the particle is y is equals to ax minus bx square. So, the path of the particle is in the form of y is equals to ax minus bx square. That means whatever the path of the or the trajectory of the particle is there, that is what ma? Parabola. That is what? Parabolic path. So, that means this particle is making a parabolic path. Okay. So now what they are asking, then find the initial velocity of that particle. We have to find what ma? Initial velocity of the particle is equals to how much? That's it. So we have the equation in this case. So have a look. Y is equals to x tan theta. This means what ma? Y is equals to ax minus bx square. After substituting a and b values, you will get y is equals to ax minus bx square. So the equation of trajectory of the particle is this, and they are given acceleration due to gravity. Ay is equals to alpha. That means g value given how much? Alpha. What they are asking? Initial velocity. We have the equation for initial velocity. What is that? U is equals to, in this case we have the formula for initial velocity when the object is making projectile motion. If its path is parabola, then its initial velocity u is equals to under root of g into a square plus 1 divided by 2b. That's it. So a value is same. They are given a is equals to a, b is equals to b. So u we have to find. They are given just g value. Acceleration due to gravity along y direction. How much ma? Alpha. So that means here they are given g value. What is that? Alpha. Just substitute here. U is equals to alpha into a square plus 1 divided by 2b. So this is the initial velocity of the object. This is the answer. Any difficulty is there? Simple problem, na? So that's why I'm saying, please focus on concept. Focus on the concept. So from the concept we have derived this formula. Okay, now. So from this concept, the equation of a trajectory. So from this equation, we have just derived this formula. Based on this formula, they are given the question. So just they are changed the value of g. In the place of g, they are given alpha. That's it. Remaining all the things are same. Okay, na? Any difficulty is there? No difficulty is there, na? So that's why I'm saying that please learn the concept. So pause the video and write the notes. 3, 2, 1. Right. So have a look. Application number 2. Application number 2. Okay. So we got the equation of trajectory. So what is that? So y is equals to x tan theta minus gx square divided by 2u square cos square theta. Okay. Right, sir. Okay. Now I want to write this equation of trajectory in terms of range. In terms of range. So what is that? Equation of trajectory trajectory in terms of range, capital R. Okay, so have a look. I'm taking this equation. So y is equals to x tan theta minus gx square divided by 2u square cos square theta. Okay now. So I'm just multiplying and dividing this part with sin theta. Sin theta divided by sin theta. Any problem? No problem is there now? Okay, sir. Right. Very good. So y is equals to x tan theta minus, here we have gx square divided by 2 into u square, 2 into u square. Here cos square theta is there. What is that? Cos square theta. I am just writing cos square theta as cos theta into cos theta. Any problem? No problem is there now. So cos square theta can be written as cos theta into sin theta divided by sin theta. Have a look. From this, here 2 is there. 2 sin theta cos theta. 2 sin theta cos theta can be written as sin 2 theta. So have a look. Y is equals to x tan theta minus gx square divided by 2 sin theta cos theta. We can write sin 2 theta. Okay, sir. We got sin 2 theta. Here u square is there. So here I am writing into u square. Okay, now 2 sin theta cos theta, sin 2 theta. U square is there. U square is there. Now have a look. One more cos theta term is there. In a numerator we have sin theta. So sin theta divided by cos theta, it becomes tan theta. That's it. Any problem? I'm just multiply and divide with sin theta. So here we have 2 sin theta cos theta, sin 2 theta. Here u square, sin theta divided by cos theta, tan theta. That's it. Okay now. Right. Next, y is equals to x tan theta minus, I'm just writing this g as, so here we have x square tan theta divided by, here we have u square sin 2 theta. So whatever the g in a numerator is there, I'm just writing that g at this place. U square sin 2 theta divided by g. Any problem? Again, if g went to what? Numerator, it becomes gx square tan theta by u square sin 2 theta. No problem is there. Okay, no problem at all. You don't worry. Okay, right. So what is u square sin 2 theta by g? U square sin 2 theta by g is the formula for range. What is range? U square sin 2 theta by g. That's it. So just write u square sin 2 theta by g is equals to r here. So you will get y is equals to x tan theta minus x square tan theta divided by what? Range. So this is the equation of trajectory in the form of range, in terms of range. Okay, right. So I'm just taking the common x tan theta. So if I take common x tan theta, here you will get 1 minus, so x tan theta, I'm taking the common, here one more x is there, so x divided by r. So this is also equation of trajectory in terms of range. So what is that? Y is equals to x tan theta bracket of 1 minus x by r. That's it. That's it. Any difficulty is there? So we have problems based on this formula. Okay now? Alright. Shall we do the problems? Okay, sir. Have a look. Right. Have a look. Example number 1. So they are given like this. So a body making a projectile motion. So the initial velocity of the object, let us say u is equals to, here I am writing 20 meter per second. At a particular instant of time t, the object is at a point p and its coordinates are 5, 5. Okay, so the remaining distance from point p is a 15 meters. Find out theta is equals to how much? Find the theta is equals to how much? That is a given question. So what we have to find? We have to find a theta. They are given u. So how to find an angle theta? So pause the video and try the solution. So this question is based on this concept only. Okay now? Right. 3, 2, 1, go. Right. I'm going to solve the solution. So what they are given? They are given initial velocity u is equals to how much? 20 meter per second. And let us use acceleration due to gravity. A is equals to g is equals to 10 meter per second square. Okay. So what they are given? They are given the position of the point P at an instant of time t. So what is that? 5 comma 5. So P is equals to how much? 5 comma 5. That means the x coordinate they are given. How much along x direction? X is equals to 5. So from origin to this point P is how much more? 5 meters distance. So along y direction, this is also 5 meters. So what we have to find? We have to find an angle theta. For that, I am using this formula. So y is equals to x tan theta into 1 minus x by r. 1 minus x by r. So xy values they are given how much? 5 comma 5. So y value is how much? 5. That is equals to x value 5 into tan theta. We have to find an angle theta. 1 minus what is the value of x? 5 they are given divided by r. So what is the value of R? R means range, the total horizontal distance traveled by the projectile body. The total horizontal distance traveled by the projectile body. So that means this is called a range from origin to point C, right? So from here to here, 5 meters. From here to here, 15 meters. 15 plus 5, 20 meters. So R is equals to how much? We got 20 meters. 20. That's it. 5 ones are 5 fours are. So 5 is equals to 5 tan theta into 1 minus 1 by 4. So 5 ones are 5. Here 1 is there. So 1 is equals to tan theta into 4 ones are 4. 4 minus 1, 3 by 4. If 4 comes to this side, it becomes 4. If 3 comes to this side, it becomes 4 by 3 is equals to tan theta. Tan theta is equals to, we got how much more? 4 by 3. So 4 by 3 can be written as tan 53 degrees. Tan 53 is equals to how much more? 4 by 3. Sin 53. What is the value of sin 53? 4 by 5. Cos 53. 3 by 5. 5 5 get cancelled out. So tan 53 is equals to how much? 4 by 3. So tan 53 is equals to 4 by 3. Tan get cancelled out and theta is equals to 53 degrees. Okay. So likewise, by using this formula, we can find the given angle made by the projectile body when it is making parabolic path. Okay, now right. So one more example problem, right? So the example number 2, your homework problem. Okay. So please solve the solution and comment your answer. So here is a ground. Okay. On the surface of the ground, there is a tower. The tower of height is h. At the top of the tower, there is a thief. At the top of the tower, there is a thief. So, and policeman fired a bullet from his gun. Okay. So he fired a bullet from his gun, and the bullet is moved like this. La 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 la. Over the head of the thief. Over the head of the thief, the bullet is moved like this, and it hits the ground. So the distance from this gun to the tower, the distance from gun to the tower is A, and again the distance from tower to the point where the bullet is, it's the ground, is again A. So A, A. That means the tower is at a mid of this ground. Okay, now, right? So now this bullet is moved like this and it hits the ground, and this distance A and this distance is also A. So find the theta is equals to how much? So the angle made by the bullet with the horizontal is equals to how much? Take initial velocity of the bullet is equals to 10 meter per second. Use the initial velocity of the bullet is equals to 10 meter per second. Can you solve that problem? Can I give the clue? Okay, have a look. So solution. Use this equation. What is that? Y is equals to x tan theta into 1 minus x by r. Use this equation. Okay. Now, on the surface of the ground, along a horizontal direction at a distance a, there is a tower. So, at this point, the thief is there. Okay, now. So, the height of the thief from the ground is how much? H. And along x direction, he is at a distance a. Now, what is a point P? What is the coordinates of this thief? Along x direction a, along y direction h. So, we got a x value, y value. So y is equals to how much? H, and x is equals to a, and we have to find the range. So this bullet is hits the ground at this point. So from here to here, distance is a. Again from here to here, the distance is a. So r is equals to how much, ma? 2a. A plus a, the total horizontal distance traveled by the projectile body. So 2a. Okay, now a comma h, x comma y. So we have x value, y value, r value. Just substitute here, and you will get the answer. Any difficulty is there? No difficulty is there na? Simple problem ma? Please do the problem and comment your answer. How much angle you got? Okay. Right. So pause the video and write the notes. Pause the video and write the notes. 3, 2, 1, go. Right. So have a look. The next application. So the application number 3. Application number 0. Okay. Right. So have a look. In case of projectile body. In case of projectile body. So this object is projected into the air with initial velocity u by making an angle theta other than 90 degrees with the horizontal. Then the velocity component along x direction. How much more? Ux is equals to what? U cos theta, and perpendicular to this we get uy is equals to u sin theta. Okay now. So along x direction, along x axis and along y axis. So we have the components. So what are those? So ax is equals to 0, ux is equals to what ma? U cos theta, and vx is equals to ux is equals to u cos theta. The final velocity component along x direction never changes. Okay, if you comes to here, acceleration due to gravity along y direction minus g, component along y direction uy is equals to u sin theta, and final velocity component at a particular instant of time t along y direction. So we got u sin theta minus gt. Okay now. So we have the formulas for range. So what is the range? So range is nothing but u square sin 2 theta by g. Okay, h maximum, height maximum is equals to 1 ma? U square sin square theta by 2g. Okay, next time of flight, tf is equals to 2u sin theta by g. So these are the formulas for range, maximum height, time of flight. So the application is, have a look, the horizontal component of velocity, the horizontal component of, important one, okay, the horizontal component of final velocity, final velocity at a half of maximum height, at half of maximum height. So what is that one? The horizontal component of final velocity at a half of maximum height. Always you should remember that the x component of final velocity, that means the horizontal component of final velocity, that is what ma? Vx never changes, that is always u cos theta at a half of maximum height, at a 3/4 of maximum height, anywhere. So it never changes. Are you getting? Okay sir. So next one, the vertical component of, the vertical component of final velocity at a half of maximum height, at half of maximum height, right? The vertical component of the velocity will be changes because along vertically downward direction on the object, the acceleration due to gravity is x. So due to, because of acceleration due to gravity along vertical direction, the velocity, final velocity component of the object will be changes. Are you getting? Okay, have a look. Here I am writing. So where we have to find the final velocity component, half of its maximum height, half of its maximum height. That means h is equals to height, h maximum by 2. That's it. So what is the formula of h maximum? U square sin square theta by 2g. This is a h maximum, u square sin square theta by 2g. Here 2 is there, into 2. Okay now. So 2 to the 4. That's it. So at this height, half of the maximum height, we have to find a final velocity component. Vy is equals to how much? Are you getting any doubts? Okay, sir. Very good. So I'm using the equation of motion, that is square minus u square is equals to 2as. V square minus u square is equals to 2as. So this is along vertical direction, y. So height is nothing but what? Displacement along y direction, sy. That's it. We have the value of sy. We know the ay value minus g. We know the uy value, u sin theta. We have to find the vy value. Okay. So vy square. Have a look. So vy square minus uy square. What is uy square? U sin theta whole square. That is equals to, here we have 2 ay minus g into sy. What is sy? Displacement along vertical direction. What is that? U square sin square theta by 4g. So u square sin square theta by 4g. Okay. So have a look. Here we have a g get cancelled out. So 2 ones are 2 twos are. So we got a vy square If minus term went to that side, it becomes plus and it has a square. So u square sine square theta minus 2g, 2g get cancelled out. Here we have u square sine square theta divided by 2. So u square sine square theta minus u square sine square theta by 2. Full minus half. Full minus half remains half. So u square sine square theta divided by 2. If square went to that side, it becomes Vy is equals to under root of u square sine theta divided by 2. Sorry, square is there. So if square went to become, so if square went to this side, it becomes root. So if u square comes from the root, it becomes u. If sine square comes from the root, it becomes sine theta divided by, here we have root 2 is there. So this is the equation for the vertical velocity component at a half of maximum height. Half of maximum height. So this is application number 3, right? So application number 4. Are you getting simple mathematics, ma? Okay, na? Application number 404. So that we have, I wanted to find out the velocity of the object, velocity of the object at a half of its maximum height, half of its maximum height. So what we have to find? We have to find the velocity of the object at a half of maximum height. The velocity, they are not saying vertical component, they are not saying a horizontal component. They have to find what, ma? Velocity, final velocity, overall velocity. Okay. So for that I am taking the velocity vector. So v bar is equals to vx I cap plus vy j cap. Vx I cap plus vy j cap. What is vx? The final velocity component along x direction. Either it is half of maximum height, either it is a 3/4 of maximum height, anywhere. So the final velocity component along x direction never changes and it is always u cos theta I cap plus vy at a half of maximum height, at a half of maximum height. How much, ma? So u sin theta divided by root 2 j cap. Root 2 j. It is in the form of vector. It is in the form of vector. I'm just going to find out it's a magnitude. So magnitude means what, ma? Under root of coefficient of I cap square, that is u square cos square theta plus this square. So coefficient of j cap square. So u square sin square theta divided by, here root 2 is there. Root 2 whole square, you will get 2. And the magnitude of v bar becomes v, that is equals to, have a look. I'm taking the LCM. So here 2 is there. 2 into this, you will get under root of 2 u square cos square theta plus u square sin square theta divided by 2, and just taken the LCM. Are you getting any doubt? Simple mathematics, ma. Okay, so nothing to explain here. This is a mathematics. Okay, so here I'm taken LCM 2 u square cos square theta plus u square sin square theta divided by 2. Okay, just pause the video and write this part. Pause the video and write this part. 3, 2, 1, go. Right. So here we got. So v is equals to what, ma? V is equals to under root of 2 u square cos square theta plus u square sin square theta divided by 2. Divided by 2. Are you getting? Right. Any difficulties there? My easy mathematics, ma. Okay. Right. So v is equals to, here u square is there. U square is there. I'm just taking u square common. Then you will get 2 cos square theta plus sin square theta under root divided by 2. Okay, so v is equals to, have a look, here u square is there, divided by 2 is there. So u square divided by 2 under root of, here 2 cos square theta is there. Here we have 2 cos square theta, and I'm just writing 2 cos square theta as cos square theta plus cos square theta. Here plus sin square theta is there. Can I write like this? Cos square theta plus cos square theta, 2 cos square theta, no problem. Have a look. Sin square theta plus cos square theta. Sin square theta plus cos square theta. Value is how much, ma? 1. This value becomes 1. So then we get v is equals to u square by 2. Here we have 1 plus cos square theta. So under root. Any difficulties there? Simple thing, ma. Simple mathematics. Okay, don't get attention. So here we have cos square theta plus sin square theta. The value of sin square theta plus cos square theta is equals to 1. So 1 plus cos square theta. That's it. So this is what we got. V is equals to under root of u square 1 plus cos square theta divided by 2. So what is this? This is the final velocity component of a projectile body at a half of its maximum height. It is not a x component and it is not a y component. It is a final velocity component. If you wanted to find the final velocity component along y direction, is given by this formula u sin theta by root 2. X is very easy, ma. Either half of maximum height, 3 by 4th of maximum height, anywhere. It is always u cos theta only. That's it. Okay. So we got the two new formulas. What are those? The final velocity component of the projectile body along vertical direction at its half of maximum height. So Vy is equals to u sin theta by root 2. So the final velocity component of the projectile body at its half of maximum height along x direction always. What is that? U cos theta only. So the final velocity component of the projectile body at its half of maximum height and not mentioned any direction. So you can use this formula. What is that? Under root of u square 1 plus cos square theta divided by 2. So whole root ma. For 2 also there is a root. Okay. Right. So we have one problem based on this application. So please pause the video and write the application. 3, 2, 1, go. Right. So have a look. I'm just giving the example problem based on our concept. Just now we have discussed. What is that? So the velocity of the object at its half of maximum height. V is equals to under root of u square 1 plus cos square theta divided by 2. So have a look what they are given. So the velocity of a projectile when at its a maximum height. So the projectile which is at a maximum height at that point its velocity is how much? Under root 2 by 5 of its velocity when at half of its maximum height. So they are given a projectile body. Okay, sir. Okay. So at a maximum height. At a maximum height. So the velocity of the object. They are not mentioned horizontal, vertical direction. Just they are saying a velocity of the object. So V is equals to how much, ma? Under root 2 by 5 of under root 2 by of its velocity when at half of its maximum height. So under root 2 by 5 times of velocity at its half of maximum height. So at this point, at a B point, what is the velocity? Under root 2 by 5 of half of its maximum height. So what is the velocity at a half of maximum height? So u square cos square theta plus 1 divided by 2 under root. So this is the velocity of the object they are given. So what they are asking, find the angle of projection. Find the angle of projection. That means theta is equals to how much? They are asking this. Okay, na? Right, have a look. So they are given now velocity of the object. So V is equals to under root 2 by 5 times of the velocity of the object at a half of its maximum height. That is u square 1 plus cos square theta divided by 2 under root 1 plus cos square theta or cos square theta plus 1, whatever it is, same. So have a look at a maximum height point B. What is the final velocity of the object? 0. Vy is equals to 0. Vertical velocity component, final vertical velocity component 0 along y direction. So and the Vx. So Vx is always is equals to Ux, that is equals to u cos theta. U cos theta. What we have to find? We have to theta here. Further, I'm just writing the general velocity equation, velocity vector equation. So V bar is equals to Vx I cap plus Vy j cap. I'm just going to find its magnitude. So V bar square is equals to so Vx square plus Vy square. Vx square plus Vy square. So V square. What is the value of V square? This is the value of V and a square for this and a square for this. So square root get cancel out. Here also square root get cancel out. Have a look here. We got 2 by 5. Are you getting now? In general, whenever we are did the magnitude, so this term becomes under root of Vx square plus Vy square. But here I am squaring on either side. Directly I am substituted. Okay, right. So 2 by 5 into u square 1 plus cos square theta divided by 2. So that is equals. What is the value of Vx square? So Vx is equals to u cos theta. Square is there. U square cos square theta plus vy square value is 0 along y direction. The final velocity of the object at a maximum height becomes 0. So have a look, 2 to get cancelled out. Here we have, so u square 1 plus cos square theta. Here we have a phi in denominator. If we went to its side, it becomes phi u square cos square theta. That's it. Here u square cut. So 1 plus cos square theta is equals to phi cos square theta. So if a cos square theta went to that side, it becomes phi cos square theta minus cos square theta. So phi cos square theta minus cos square theta, 4 cos square theta. If 4 comes to this side, it becomes 1 by 4 is equals to cos square theta. If square comes to this side, it becomes cos theta is equals to 1 by 4 under root. So root 1 by 4 value becomes how much ma? So cos theta is equals to 1 by 2. Are you getting? Simple mathematics. Okay. So square root to that side, this side, sending this term to that side, that term to this side, all these things, mathematics. What we have to do? Nothing we have to do, just we have to do the solution. So cos theta is equals to 1 by 2. 1 by 2 can be written as cos 60 degrees. Cos 60 degrees is equals to how much more? 1 by 2. So cos get cancelled out and theta is equals to 60 degrees. So that is the answer. So the angle of projection theta is equals to how much more? 60 degrees. Okay na? So this problem and this example problem is also depends upon our concept. What is that? So the velocity of an object at a half of its maximum height. Okay na? So please learn the concept. That's it. Right. So the last concept of today's session. Sir, last concept? Yeah. Okay. That is kinetic energy and potential energy of a projectile body. Of a projectile body. Okay. Right. Have a look. I'm just projecting the object by making an angle theta other than 90 degrees with the horizontal, and it makes a projectile motion. This is called a range, and the initial velocity of the object, let us say u. Let us say u. So capital A is the point of projection, and this is B, and this is point C, and this is what now? H maximum. Okay. Right. So note number 1. First one. So at a point of projection, the total energy of an object is stored in the form of kinetic energy. Is stored in the form of kinetic energy. So at a point of projection, at a point A, so whatever the energy of the projectile object is there, whatever the energy of projectile object or body is there, the total energy is stored in the form of kinetic energy. Total energy of projectile body at a point of projection is stored in the form of kinetic energy. It is a pure kinetic energy. It is what ma? Pure kinetic energy. Completely, the object has only kinetic energy. Okay na? So total energy E total is equals to half m u square. This is the formula for kinetic energy. So total energy of the projectile body at a point of projection is purely kinetic energy. That is half m u square. Are you getting? Okay. So note number 2. At a maximum height, the kinetic energy of the object given by at a maximum height so the kinetic energy of the object at a maximum height is equals to half m vx square plus half m vy square at a maximum height. At a maximum height, the vertical velocity component is 0. So the horizontal component of the velocity anywhere along x direction, either it is final or initial, equals to u cos theta. So at a maximum height, Vy is equals to how much ma? 0. So kinetic energy is equals to half m Vx. What is the value of Vx ma? u cos theta whole square. Okay na? Right. So note number 3, the potential energy of projectile body at a maximum height. So potential energy at a maximum height is given by, so in general potential energy formula is what ma, mgh, where h is what, maximum, it is a maximum height. Here we have mg. What is the formula for h maximum? H maximum formula is what ma? So u square sin square theta divided by 2g. So gg get cancelled out, and the potential energy at a maximum height we got m u square sin square theta divided by 2. Okay na? Right. Okay, any problem? So these are the three important notes. Okay, right. So pause the video and write the notes. Pause the video and write the notes. 3, 2, 1, go. Right. So this is the end of the today's lecture. I hope that you are understood the concepts and example problems. So with this, the trajectory of a projectile body is parabola concept is over. So we will meet on a next lecture, that is projection of a object from inclined plane. So down to up, up to down. Okay. So we will meet on the lecture, and it's time to say signing off. Can I say? Right. So this is Rakesh Kanaganti signing off. Stay tuned. Jai Hind.